Page number 62, 4.5.7 theorem. Okay. All of you, the theorem is 4.5.7 theorem in third part. Third part, it is also, second part is completed. This notes is okay. This is the third part is 4.5.7. Okay, all of you listen. Yes. Okay. Now, given that, వినబడుతుందమ్మా? Okay.
Yes, sir. వినబడుతుంది, sir.
Given that H is a proper subgroup of G. Okay. So proper subgroup is means H not equal to singleton he, H not equal to G. Suppose H is equal to singleton he, H is equal to G, is a trivial normal subgroup. Proper subgroups is H not equal to E, H not equal to G. Then we prove that. So then we prove that H is contained N of H. మనకేం ఉండాలి? Normalizer of H contained N of H. Where N of H, okay, where N of H is equal to X is element of G such that XH is equal to HX. So this is a normalizer definition. H is N of H contain H, N of H is equal to X element of G, H of X is equal to G. So let ఇక్కడ K ఏం తీసుకుంటున్నాం? K be a maximal normal subgroup of G. Symbol వేసిన K be a maximal normal subgroup of G contained in H. Contained in H. K be a maximal normal subgroup of G contained in H. So that is the meaning is clear. K subset are equal to H subset of G. K is a maximal normal subgroup. Ikkada G is a group. Okay. H is a subgroup of G. Ikkada this is K maximal normal subgroup of G. H subgroup of G. Ikkada K is a maximal normal subgroup of G contained in H. That is called this. So G bar is equal to G by K. G by K is means normal subgroup of G. This is a normal subgroup of G. G by K is called as a quotient group. Be a quotient group. Quotient group was so many times చెప్పాను. Quotient group లో left cosets, right cosets are there. Quotient group of K in G. That is G bar and the same order of G bar, order of G by K, order of G by K, order G by order K. Order G and ఏం తెలుసు? P by N. So order K is means PL. So this is PL ఎందుకు? This is a concept. Lagrange's theorem. Order K divides order G. Order K divides order P power of N. Order K must be N కంటే తక్కువ ఉండాలి. L is less than N. So కాబట్టి order K P power of N. So order G bar is equal to power P power of N minus L. P power of N. Where N minus L greater than 0. N minus L greater than 0. This is the first part. So it is called is already first part tells N minus L greater than 0 okay, by first case. What is the first case? it has non-trivial center. G bar as a group of order G is equal to first తీసుకున్నాం group order G is equal to p power of n greater than 0 అయితే it has G is a non-trivial center. ఇక్కడ what happened? G in plus G bar is equal to p power of n minus L, where n minus L greater than 0. Then G bar has as a non-trivial center, as a non-trivial center, a non-trivial center, a non-trivial center, non-trivial center, and Z of G bar, order of Z of G bar is greater than or equal to P. So order of Z of G bar is greater than or equal to P. Okay. Hence there exists a normal subgroup of G, a normal subgroup L of G, normal subgroup L of G. So normal subgroup L of G. So such that this is called such that symbol Z of G bar is equal to L by K, a normal subgroup of G by K, where K not equal to capital A. Okay. So this is a quotient group. This is a quotient. L by K also quotient group. G by K also quotient group. L by K quotient group. G by K quotient group. L by K లో ఎలిమెంట్స్ ఎట్లుంటాయి? xk is a left coset, belongs to L by K, is equal to ఎక్కడ ఉంటుంది this element? Z of G bar. So what is the center of a center? This is a center of a group. Center of a group property, a commutative property. The center of a group will be satisfied a commutative property. And here easily listen to me. This is a call this G bar is equal to G by K. This is center of G bar. Center of G bar అనేది quotient G by K. Center of G bar L by K. Center of G bar లో whose element? xk is the element of G bar is equal to G by K. Center of G bar is equal to whose element? xk. This element center definition, commutative property. What is the commutative property? xk is equal to yk. xk is equal to yk, commutative property. Sorry, xk into yk is equal to yk into xk. This is a AB is equal to BA. But elements, center of G bar whose elements? Cosets element. xk into yk is equal to yk into xk for all yk. For all yk element of G bar is equal to G by K. Okay. What is the property for? So I am taken for y belongs to H. This property, product of left cosets, right? Left cosets xy into k is equal to yx into k. Two left cosets formula already also AH is equal to BH if and only if A inverse B belongs to H. Same model. H in plus K. So xy into k, yx is equal to k. What happened is xy whole inverse into yx is belongs to k. xy. So what is the AB whole inverse? AB whole inverse is now. So this is xy into yk whole inverse. AB whole inverse is equal to what is the formula? Y inverse x inverse into yx is a belongs to k. Y inverse whole inverse into yx is belongs to k. So what happened? Then both sides we can do apply y element. This is a y element to y inverse x inverse yx is a belongs to yk. నేను ఏం చేసిన ఈ లెఫ్ట్ సైడ్ y ఎలిమెంట్ ప్రోడక్ట్ లెఫ్ట్, దిస్ ఇస్ y ఇన్వర్స్ ఈ కాబట్టి నాకు ఏమిగుతుంది ఓన్లీ. సో దిస్ ఇస్ ఓన్లీ y x ఇన్వర్స్, ఓన్లీ ఏమిగుతాయి ఓన్లీ దిస్ ఇస్ x ఇన్వర్స్ ఆఫ్ yx బిలాంగ్స్ టు yk. సో yk ఈజ్ ఆల్వేస్ సబ్సెట్ ఆర్ ఈక్వల్ టు h, ఎందుకంటే వి నో దట్ k subset r equal to h, yk subset r equal to h, y belongs to h కాబట్టి. So what happened is called is x inverse of y, x is belongs to h. belongs to H. So belongs to H. That is for so X belongs to uh, L, Y belongs to H. We have X inverse of Y, X is belongs to H. H is a normal subgroup like that. X inverse of H for all Y belongs to H. X inverse of H, X, X inverse of H, X belongs to capital H. ఎందుకు for all Y belongs to H. నేను ఇక్కడనే తీసుకున్నాను. Y belongs to H. So Y belongs to H. We have. So ఇక్కడ ఏమొచ్చింది X inverse of H, X subset are equal to H for all X belongs to capital L. X belongs to capital L. అంటే we have to left side. So this is a property is a, already we know that H subset are equal to X inverse of HX. ఈ రెండిటి నుంచి these two నుంచి ఏమైతే therefore X inverse of H of X is equal to H. So for all X belongs to capital L. ఈ X inverse అటు పంపియండి. This implies HX is equal to so XH for all X belongs to L. So okay. Next, what happened? This is a property. What is a n of H? XH is equal to HX. What happened? N of H. So n of H, what this is implies. So X belongs to n of H. X belongs to n of H by definition. What is the X? L. What this is L subset are equal to n of H. So that is L is means K. K subset of L subset are equal to n of H. So we that it is, but we know that, so we know that is equal to H subset are equal to n of H. So it's a clear H is equal to n of H. H is equal to n of H. So K subset are equal to n of H is a contradiction or observation that H not equal to n of H. So H not equal to n of H. H subset are equal to L of H iskunte K subset of L of H subset are equal to n of H is a contradiction. But therefore H not equal to n of H. And what is equal కాదు, only H is the, so this is a only H is the, so is the meaning is it's a clear only H is the H, therefore H not equal to n of H. కాబట్టి here 100% sense ఏమవుతుంది? H is a properly contained in n of H. Contained in n of H. కాబట్టి H is properly contained. N of H is properly contained H, or H is contained n of H is a clear. That is a next is the fourth part. What is the fourth part? The subgroup order is equal to p power of n minus 1. Since n of H is the largest subgroup of G in H is a normal. So one theorem is there. N of H is the largest normal sub. N of H is the largest subgroup of G in which H is. N of H is the largest subgroup. N of H is the largest subgroup of G in which H is in which H is normal. H is normal. One theorem. So we get H subset are equal to N of H subset are equal to చూడండి. N of H is the largest subgroup of G in which H is normal. So the order, both side order H subset are equal to order of N of H is less than or equal to order G. This is a order p power of n minus 1 less than normalizer of N of H is less than or equal to p power of n. So p power of n. So a group order G is equal to p power of n. Koti ఇది ఈక్వల్ కాదు 100%. This is a must be equal. Koti the order of N of H is equal to p power of n. P power of the order of N of H is equal to p power of n group order G. ఈ రెండు ఈక్వల్ కాబట్టి these two equal. So N of H is equal to G. So N of H is equal to G. So this is H is a normal in N of H and మనకి ఏం తెలుసు, therefore H is normal in N of H and N of H is equal to G. So N of H is equal to G got up H ఏమవుతుంది? H is normal in G. So that is clear. H is a normal subgroup of G. This is the clear is completed in the fourth part. Next, we are topic is 4.5.9. So the topic is 4.5.9. So 4.5.9 topic is called P is a prime number. A group order P square is equal to abelian. Say every group of order P square. Ikkada, what is now every group of order P square is abelian. Given that, ikkada. So every group of order P square given that G is a group, order G is equal to P square. Where is a P prime number? So if possible, suppose that G is a non-abelian group. So then G not equal to Z of G. G is a abelian, it means G is abelian. G is abelian. So G is abelian if and only if G is equal to Z of G. So not equal to this G is not abelian. Not abelian. So not abelian. So not abelian. If and only if this is G not equal to Z of G. G not equal to Z of G. The G not equal to Z of G and since Z of G is a subgroup of G. Z of G is a so G is a abelian. If and only if G is equal to Z of G, G is a not abelian. It is a proper subgroup. Z of G is a subgroup of G. Z of G is a subgroup of G. So subgroup of G, what is a Lagrange's theorem? So this is a Lagrange's theorem. So we call this apply the Lagrange's theorem. So Z of G is a subgroup of the order of Z of G is a subgroup of a group order G. So is a group order. So subgroup of Lagrange's theorem, the order of Z of G. So order divides a group order G. A group order G. Order of Z of G divides group order G is equal to P square by Lagrange's theorem. So what is the Lagrange's theorem? Order G. ఇక్కడ చూడండి. So I am to rough column. Order of Z of G is a possibility. ఈ పీ స్క్వేర్ డివైడ్ చేసే పాసిబిలిటీస్ ఏమొస్తాయి? 1, P స్క్వేర్. ఇది 1 కాదు, పీ స్క్వేర్ కాదు. 100% ఏమవుతుంది? షుడ్ బి పి. అంటే దేర్ ఫోర్ 100% ఈస్ అంటే 1 ఈజ్ ఏ గ్రూప్ ఆర్డర్ 1 ఈజ్ ఏ ట్రివియల్. గ్రూప్ ఆర్డర్ పీ స్క్వేర్ నాట్ ఈక్వల్ టు ఆల్రెడీ మనం తీసుకున్నాం. Z of G not equal to G. P square possibility కాదు. 1P P square. 1P P square. This is a group order G. This is a G is equal to singleton E. It's not possible. It's not possible. Only that is order of Z of G is equal to P only. Order of Z of G is equal to P only. So that is a concept is therefore Z of G subset or G is there exists a element of G. A does not belongs to Z of G. A does not belongs to Z of G. Equation 1. So we know that. So we know that. So we know that we have to apply. We know that every Z of G subset are equal to normalizer of A. So but we here Z of G is not subset or equal to normalizer of A. So since order of Z of G is equal to P, so Z of G is a subset of normalizer of A, and every normalizer, ante Z of G is a normalizer. Normalizer is a subgroup of G. Normalizer is a subgroup of G. Ante what I point? Z of G subset of normalizer of A, subset are equal to G. This is the Bode's order. Order of Z of G. So less than order of normalizer of A is less than or equal to order of G. So Koti is a subgroup of G, and a group of order of A is a divides a group order G. Order of normalizer of A. So this is the Lagrange's theorem. So this is the group order G is a P square. Group order G is called P square. 100% to ikkada what is the relation? This relation P is less than order of N of A is less than or equal to P square. 100% దేనికి equal కావాలి? The order of N of A is equal to P square. So order of N of A is equal to P square. Order of N of A is equal to P square అంటే it is a group order G. Group order G అంటే therefore order of normalizer of A is equal to G. Order of normalizer of A. What is the normalizer of A definition? What is the normalizer of A definition? X element of G such that XA is equal to AX for all X element of G. So this is a every this is the definition. N of A, actually you know N of A. This is N of A. Can we know that N of A is equal to G?
సార్ నోట్స్ రీసెండ్ చేయండి సార్ ప్లీజ్.
Once again reverse. A commits with every element of X. Two types of the sentence. Every element X of G. Every element X of G commits with A. Every element X of G commits with A. A commits with every element X of G. So, therefore, A is a element of center of G. So, which is a contradiction. When starting is A does not belongs to Z of G. This A belongs, which is a contradiction to equation 1. Our assumption that what happened is A does not belongs to Z of G, equation 1. We know, show me A belongs to Z of G, which is a contradiction to equation 1. Our assumption that G is a non-abelian group is wrong. 100% to 100%, hence G is abelian. 100% G is abelian. So 100% G is abelian. So that is G is a abelian. Now, no, G is a abelian. Now, it is a clear from, this is the theorem, is all of you. 4.5.9 theorem is completed. So this is it is a called this 4.2, 5.12, remaining 4.5.12, this theorem name is called Bernoulli theorems. State and prove that Bernoulli theorem good and 4.5.12 theorem, Bernoulli theorem alter. So state and prove that Bernoulli theorem. So I will get to the, this is the Bernoulli theorem. So what is the Bernoulli theorem is the concept is same thing. So statement is a Bernoulli theorem. These notes also I have to send your notes also in group Bernoulli theorem. Same way. So we have to apply the concept is Bernoulli theorem.
ప్రీవియస్ నోట్ కూడా ఒకసారి సెండ్ చేయండి సార్. మళ్ళీ ప్రీవియస్ నోట్స్ కూడా ఒకసారి సెండ్ చేయండి సార్.
మొత్తం ప్రీవియస్ విత్ ప్రీవియస్ నోట్ తో సహా పిన్ చేసి there is no problem. Already I will send this. So this is a Bernoulli theorem statement. Your textbook G be a finite group and a finite set X. The number of distinct orbits in X equal to 1 by order of G, summation of A belongs to G, order of XA. XA is equal to small x belongs to capital X, such that AX is equal to X. So this is the concept is we have to clear. AX is equal to X undi. I am taken GX is equal to X is not. So we are interested in anyone. So it is a concept is the theorem is. Let this is the proof Bernoulli theorem. So what is the theorem statement is 4.5.12. 4.5.12. So what is the 4.5? Let S is equal. What is the S is equal to? We have to apply the ordered pair G comma X so belongs to G Cartesian product capital X such that Gx is equal to X. Actually textbook law Ax is equal to X. Small a is element of G. ఇక్కడ ఆర్డర్ పేర్ AX ఉండాలి కానీ నేను taken gx is equal to x or ax. For any fixed element to g, the number of ordered pair. For any fixed element, this is a fixed element of g. For any fixed element of g, the number of ordered pairs g comma x, the number of ordered pair g comma x in S, exactly the order of xg, the order of xg. Similarly, for any fixed, ikkada fixed element to g, fixed element to, for any fixed element to small x belongs to capital X. So in order of gx is the number of ordered pairs in g comma x in S. So in S, the order of S is equal to the summation of small g belongs to capital G, the order of xg equal to the summation small x belongs to capital X, such that the order of x. So the order of x. So it is a equation. By theorem 4. By theorem we know that already. We have to concept is it is a orbit of x is equal to the index of, so is already the orbit of x index of like this. The order of g by order of gx is already, we have to theorem proof already completed. Orbit of x stabilizer group. This is a orbit of x. This is a stabilizer group is equal to order g by x. So the orbit is the orbit of x gx is equal to the order g by order g suffix x. G suffix x is called is stabilizer group. Gx is called is orbit of x for all small x belongs to capital. Interchange the rows. So g suffix x is equal to order g by order stabilizer group. Interchange for small x belongs to capital X. These are both sides summation apply. The summation of small x belongs to capital X, the order g suffix x is equal to the summation of small x belongs to capital X, the order g by, so the order of g by order orbit of x. So orbit of x. So this is a small x apply. Again, the summation in small g fixed element of g, such that is order of xg is equal to summation of x element of x. Those two, these are equal. So the order g by the order stabilizer group, the order by equation 1 by equation 1. Already I am taken. This is a equation 1. Both are equal. So this is take separately order g. So take right here summation of small x belongs to capital X 1 by the orbit of x. Orbit of x. This is a small g is equal to summation of small a belongs to c. So it is applied summation of x belongs to GA. This is 1 by orbit of x. 1 by orbit of x. This is applied. Your second equation. Where C, so this is important. Where C is, I am to write here. Where C is the subset of x, subset of capital X, containing exactly one element from each orbit. What is the sentence? Read them. Where C is the subset of capital X, containing exactly one element from each orbit. So each orbit. So it's a clear. So next, now again in continuation. So for any, so it is a for any small x belongs to gx. So it is a, we have a gx is equal to g of a. So for we are both are summation of x belongs to ga. So 1 by orbit of x. So 1 by orbit of summation of x belongs to ga. So ga 1 by ga in, so x in plus in, so small x in belongs to small a, ga. So what does that means? Is equal to 1 by order of ga orbit, the summation of x belongs to ga into 1. So 1 by order of ga is equal to, so 1 plus 1 plus 1 plus, so summation 1. How many times? ga times. That is called 1 by ga into ga times is means order ga. So this is ga cancel, it is a 1. So what is the equation? Summation of x belongs to ga orbit of ga 1 by gx orbit of x is equal to 1. This is equation number 3. Equation number 3. In equation number 2 we have, so we have, this is summation of small g belongs to capital G, the order of xg is equal to order of g. So it is a summation of a belongs to c into 1. So the order of g into order of c. So this is order of g into order of c is equal to k. This is a k. So where is the order of C is equal to small k. So this is a small k. This is a summation of small g belongs to capital G into order of xg is equal to, what is the k? K is equal to 1 by. So k is equal to 1 by order of G. Summation of small g belongs to capital G, the order of xg. So the order of xg. This is a hence proved. So k is the Arabic number of Arabic. This is a Bernoulli theorem. So same the I am to explain the notes. I will send the Bernoulli theorem. So your textbook is Bernoulli theorem. మీకు XG ఉంటుంది, ఇక్కడ టెక్స్ట్ బుక్ లో XA ఉంటుంది. దట్ ఇస్ అ డిఫరెంట్. సో సేమ్ వే. నెక్స్ట్ ఇస్ we have to example 4.5.13 example. In 4.5.13 example is it's a clear from 4.5.13 example, page number 64. So the
సార్ అన్మ్యూట్ చేయండి సార్, మ్యూట్ లో ఉంది.
okay. Consider ఇక్కడ చూడండి. Let A is element of G such that A not equal to E. Consider the conjugate classes. Two conjugate classes. A conjugate classes అనుకుంటున్నా. Consider singleton E one conjugate classes and C of A another conjugate classes. Then it is then G is equal to ఏమవుతుంది? The conjugate classes of union singleton E union a conjugate classes of A. This is equation 1. So let ham taken B not equal to E another element. A not equal to E అయితే order of A is equal to n. మనకు order of A definition ఏంటి తెలుసు? A power of n. A power of n is equal to E అయితే order of A. So this is the definition. B not equal to E. B not equal to B any other element. B any other element. So order of B equal to కూడా ఏం కావాలి? n కావాలి. ఎందుకు? సిన్స్ ఆర్డర్ ఆఫ్ ఏ ఈజ్ ఈక్వల్ టు ఎన్. ఏ అనే ఎలిమెంట్ ఏ నాట్ ఈక్వల్ టు ఈ తీసుకుంటే ఆర్డర్ ఆఫ్ ఏ ఈక్వల్ టు ఎన్. బి నాట్ ఈక్వల్ టు తీసుకుంటే ఆర్డర్ ఆఫ్ బి ఈక్వల్ టు ఎన్. నౌ షో దట్ ఏం ఉంచాలి? దిస్ ఈస్ ఎన్ ఈజ్ ప్రైమ్. అక్కడ ఇక్కడ ఎన్ ప్రైమ్ అని చూపించాలి. ఎన్ ప్రైమ్ చూపించాలంటే ఏం చూపించాలి? ఏ నెంబర్ షుడ్ బి ప్రైమ్ నెంబర్. ఇట్ ఇస్ ద డివైడెడ్ బై 1 and itself number. అయితే దట్ ఈస్ ద ప్రైమ్ నెంబర్. సపోజ్ నేనేం తీసుకుంటున్నా? సపోజ్ ద నెంబర్ m డివైడ్స్ n. n ప్రైమ్, యూ కెన్ షో మీ n ప్రైమ్. అంటే వాట్ యూ కెన్ షో మీ m ఈజ్ ఈక్వల్ టు n ప్రూఫ్ చేస్తే దట్ ఈస్ ద ప్రైమ్. కానీ వాట్ ఈస్ ద డివిజన్ ప్రాపర్టీ? m డివైడ్స్ n అయితే n ఈజ్ ఈక్వల్ టు mk. ఫర్ సమ్ k బిలాంగ్స్ టు z. సో కన్సిడర్ ద cyclic group G generated by consider the cyclic group generated by A. అంటే G is equal to cyclic group generated by A అంటాం. cyclic group generated by అంటే దెన్ కంపల్సరీ దీని యొక్క స్ట్రక్చర్ ఎట్లుంటాయి? a power of n such that n belongs to z. So this is a power of n is equal to e. Both side k apply chandi. A power of n is equal to k. A power of so a power of n mk. A power of m is equal to some n belongs to n. Both side a power of k tan products and a power of mk also is equal to e. So this is a power of k whole power of m is equal to e. So then a power of k whole power of m is equal to e. So what is the a power of k is equal to, I am to taken b power of m is equal to e. Since I am taken b is equal to a power of k, let assumption a power of k is equal to b element, b power of m is equal to e. B power of m is equal to order of b is equal to m. So, but nakem telusu, this is a b is equal to conjugate class of a. What is the conjugate class of a definition? This is order of b. Conjugate class యొక్క structure ఎట్లుంటది? xa x inverse such that x element of g. So, what happened is b is equal to xa x inverse. Then order of b is equal to ఏమవుతుంది? Order of a. ఈ రెండు ఈక్వల్. What is the order of A? Order of B, M. Order of A, N. M is equal to N. M is equal to N అయింది. So I am taken M divides N. M divides N. M is equal to N. Therefore, N is prime. N is prime. Prime అందించున్నాం. We shall show that. Next to B, prove that. We prove that. We prove that. Next ఏం చూడాలి? This is A square is equal to E. A square is equal to E చూస్తే this. And I have to taken the wrong sentence. What is the wrong sentence? If it possible, so if it possible, a square is not equal to e, a square not equal to e. So a square not equal to e అయితే a square compulsory ఎక్కడ ఉండాలి? Is a belongs to conjugate class of a, belongs to conjugate class of a. So what is a square is a belongs to conjugate class of a. Then a is equal to structure and the a square is equal to conjugate class a structure. X a x inverse అంటే ఇక్కడ ఏం లేకపోతే 1 ఉన్నట్టు. For some x is element of g, then a square whole power of 1 is equal to x power of n into x inverse. So show by induction that. So it's a clear. I have to taken this is called this. So we have to apply so this is a square value. A square value same thing. Then I am to take and this is a power of 4. A power of 4 అంటే a square into a square. A square into a square is a means, what is the a square? X power of 1 a into x power of minus 1. X power of 1 a into x power of minus 1. ఈ రెండు ఐడెంటిటీ. These are identity. అప్పుడు x a into e into a into x inverse. EA x a into a into a into x inverse. X a into a square x inverse. What is the a square? Well, again put them x into a square value, x power of 1 a into x inverse into x inverse. This is x into x square a into x power of minus 2. This is a power of 4. A power of 4 నేను రాసుకోవచ్చు 2 square. A power of 2 square is equal to x square a power of x power of minus 2. A power of 4 ని ఈ విధంగా రాశాను. So next to a power of 8 నేను రాసుకోవచ్చు. We can do this is a power of 8 into a power of 4. What is the a power of 4? I am to apply a power of 4 value. So a power of 4 value తెలిసింది. What is the a power of 4 value? X power of minus 2 into this is x power of 2 into a into x power of minus 2 into x power of 2 into a into x power of minus 2. Mali again identity. So x square into identity a into x power of minus 2. This is x square into a square into x power of minus 2. So well again x square a square value substitute. What is the a square value? X a into x power of minus 2. Well again product to x into x cube x into this is x inverse x power. So this is a x cube into a into x power of minus 2. This is a2 cube is equal to a power of 8. Which is the relation? Very important. A power of 2 cube is equal to a power of 8. A power of square, A power of 4 is equal to this relation. A power of 4, A2 square is equal to A power of 2, A into F power. This is the A2 power of 1. A2 power of 1 is equal to, this is important, children. A2 power of 1 is equal to relation x power of 1, A into x power of minus 1. A2 power of, A2 power of 2 square, what is the relation? X power of 2 into A power of x minus 2. A power of 2 cube is equal to relation this is x cube into x cube also x cube. Ante we know generalization. In general. So in generalization, a power of 2 power of 5. A power of 2 power of 5 is equal to x power of 5 into x power of minus. మీరు అప్లై చేయండి. I is equal to 1. A power of square. I is equal to A power of 2 square. A power of 4. I is equal to 3. A power of 8. And this is the relation. In particular, I is equal to n. A power of 2 power of n. A power of 2 power of n. A power of 2 power of n is equal to x power of n into A into x power of minus n. X power of n into x power of minus n. So A power of 2n. So this is already, it is a relation. X not equal to E. Order of x is equal to n. So this relation, order of x, and it is a definition, if and only if definition, x power of n is equal to E. X power of n is equal to E. X power of minus n is also E. And this relation, A power of 2 power of n is equal to, much in the relation, E into A into E. So A power of 2 power of n is equal to A వస్తుంది only. A power of 2 power of n is equal to A, this power of n. So this power of n. It is also, we take left hand side, A power of 2 power of n. So we can take once again, you read the right here. It is a clear from what is the relation? ఇక్కడ చూడండి. So this is a relation. A power of 2 power of n is equal to A. So A power of 2 power of n into A inverse, left hand side product, and right side also, A into A inverse also product. A power of 2 power of n minus 1. Basis equal. Power should be added. So this is A power of 0. And it is a power 1. It is equal to, this is A power, A into A inverse is identity. So this is A power of 2 power of n minus 1 is equal to identity. Can be written as A power of nk. A power of nk. ఎందుకు సార్ అంటే A is a does not belongs to E. A is equal to E. Is like that. It is a power of, order of A power of n is equal to A. Order of A is equal to n. If and only if definition, A power of n is equal to E. A power of n is equal to అయితే product power k. A power of nk is equal to E power of k. A power of nk is equal to E. Okay, E is can be written as, this E can be written as E power of A power of nk. Basis equal, basis same, equal, the power should be equal. 2 power of n minus 1 is equal to nk. 2 power of n minus 1 is equal to nk. What is the divide definition? N divides 2 power of n minus 1, which is not possible. Which is not possible. So not possible. Which is not possible. Which is not possible. N divides. ఎందుకు why sir? N is prime. N is prime. Prime we can start to 2 number. 2, 3, 5. N is equal to 2 పెట్టండి. 2 square minus 1. అంటే 2 పెడితే ఏమవుతుంది? 2 square minus 1. 2 square minus 1 అంటే 4 minus 1. 2 divides 3. It is a possible. A number system లో this is not possible in the number system. 100% 2 does not divide 3, which is not possible. ఎందుకు not possible? నేను already we take the wrong sentence. What is the wrong sentence? Our assumption that. So this is our assumption that ఏం తీసుకున్నాను? A square is not equal to E is wrong. Is 100% wrong. 100% ఏం కావాలి? A square equal to E. A square is equal to E అంటే meaning is if and only if O inverse A is equal to A inverse. So A is equal to E. So G is a abelian group. G already is abelian group. G is a abelian group. So conjugate class of A definition. What is the conjugate class of A? We can do apply GA G inverse such that G is an element of G. G is a abelian group. G is a Hebelian group. A is equal to conjugate class of A. The conjugate class of A is equal to, what is the G Hebel? A comma G is the element of a group G. So what is the Hebelian group definition? AG is equal to GA. So ఏదో నాటు పంపియండి. A ఇక్కడ నుంచి GA, GA, G inverse. G right side. GA. A is equal to what happened? GA, G inverse. GA, G inverse we can do apply. A conjugate class of A is equal to GA, G inverse is equal to small a. Small a is element of G. So small a and CA conjugate class of A is equal to singleton A. And already G is equal to ఏం తెలుసు నాకు? Singleton he a union conjugate class of A. So singleton he union conjugate class of A, singleton he, singleton he, E comma A. So G is equal to he comma A, order of G is equal to 2. Order of G is equal to 2. So is order of singleton he union conjugate class of A. Conjugate class of A is equal to singleton A. E comma A in order of G is equal to 2. So the order of G is equal to 2. What is the number of conjugate classes 2 I think, then prove that order of G is equal to 2, proof completed. So this is our topic is completed. We are go to the topic is unit 5. So we can do apply unit 5. So this is unit 4 is completed. Now unit 5 Silos theorem topic is important. Now I'm taken is the 5.3.1 in Cauchy's theorem for Hebelian group. 5.3.1 Cauchy's theorem for Hebelian group. So Cauchy's theorem for Abelian group. My notes already, Cauchy's theorem notes I will send there. Okay. This is the 5.3.1 theorem. So important unit 5. We are going to unit 4 is completed. So 5.3.1. So I will the notes send this one. Okay, all of you. Numbers will be decreased. Starting class will be 30-40 members. Today only 17 members will be present. Okay. All of you. First of all, we definition P group definition. P group definition is called is PBA prime number. PBA prime number is a prime. A group G is said to be P group if order of every element in G is some power of prime. Example, G is equal to 1 minus 1, I comma minus I. This is order of 1 is equal to 1. This is a 2 power of 0. Order of minus 1 is equal to 2 in 2 power of 1. Order of I is equal to, what is enough? 4. It is a 2 square. Order of minus I is equal to 4. This is a 2 square. Every element in a group, every element in some power of prime. Every element in 7. Every element of G is a power of 2 in power of 2. Every element of a group G is some power of prime. That group is called as a P group. Okay. P subgroup ante P be a prime number, a subgroup H of G, a subgroup H of a group G. That H is said to be P subgroup if you order of every element in H. is some power of prime. So it is a G is equal to 1 minus 1, I minus I. So what is the H is a subgroup? 1 minus 1, H is a subgroup of G. H lo elements and also we know the order of 1 is equal to 1. This is the 2 power of 0. Order of minus 1 is equal to 2. This is the 2 power of 1. H2 elements, whose elements? The number of elements in H is a order is some power of prime. That subgroup is called this P subgroup. Okay. So it is a called this V discussion is called this. Okay, it's a nice. Next is Cauchy's theorem for Hebelian group. Cauchy's theorem for Hebelian group 5.3.1. So 5.3.1 Cauchy's theorem. This is the Cauchy's theorem. GBA finite Hebelian group order n and PBA prime number divides n. Then G as an element of order P. ఇక్కడ చూడండి. PBA prime number. G is a group of order n. Group of order n. Group of order. P divides a group of order G. P divides group order G. Or P divides group order n. Then G has an element order P. Element A అనుకుంటే element of order P. P divides group order G. P divides N. P group divides group order G. Then G has an element of order P, where P is the prime number. Element order discussion, that group is called as cyclic group. Element order discussion, that group is called as cyclic group. Element order discussion, that group is called as cyclic. Okay. So all of you, we discussion is called as G is a finite abelian group. We can do this is called as we have to the theorem proof student. This is a proof. So let G be a finite abelian group. 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 And P is prime number. P be a prime. P be a prime. So P be a prime. P divides group order G. Then G has an element of order P. So finite P is a prime. So that is group order G is equal to N and P divides N. So it is a, we prove the result. We prove the result by induction. So we prove the result by induction on N. For N is equal to 1. For N is equal to 1. There is nothing to prove. Assume that first of all, we prove the result. We prove this result by induction on N. So for N is equal to 1, there is nothing to prove. Okay. So assume that this is important. Assume that the result is true. The result is true for all groups of order or groups of order M. So with groups of order M with M is less than N. M is less than N, the theorem result is true. What is the result? Oh, it is a P prime number divides group order in it. G has an element of order P. This is the case 1. This is our first case proof. Let G be a cyclic group. నేను ఇచ్చిన నోట్స్ లో ఈ G ప్లస్ లో నేను ఇచ్చిన నోట్స్ లో క్యాపిటల్ ఏ ఉంటది, కన్ఫ్యూజ్ కావద్దు. ఐ విల్ సెండ్ ద నోట్స్ ఇన్ క్యాపిటల్ ఏ, దెర్ ఇస్ నో ప్రాబ్లం. ఇక్కడ ఏ అన్న G అన్న సేమ్, కానీ నేను మీకు జీనే ఎక్స్ప్లెయిన్ చేస్తాను. GBA cyclic group. So then there exists an element. A is an element. So what is the element? An element. So A is element of G such that, so a group order G is equal cyclic subgroup generated by A. GBA cyclic group, there exists an element of G such that this is a cyclic group definitely. G is equal cyclic subgroup generated by A. So since నాకు already తెలుసు, so P is a prime number divides group order G. P prime number group order P divides group order G. P divides group order G అంటే cyclic subgroup generated by A. So cyclic subgroup generated by A. There exists a cyclic subgroup. There exists cyclic subgroup H. Cyclic subgroup. ఇప్పుడు P divides cyclic group generated by అయితే ఒక subgroup ఉంటుంది. The subgroup order is so P. So the subgroup order is P. The subgroup H, the subgroup of H of G with compulsory order of H is equal to P. Ante P divides a cyclic group generated by A. There exists a cyclic subgroup H of G with order of H is equal to P. Order of H is equal to P. So order of H is equal to P. So order of H is equal to P. So ఇక్కడ చూడండి. So what is a G is a cyclic group. So this is H is a the order of H is equal to P. Cyclic subgroup generated by A. So ఇక్కడ what is a P divides a cyclic group divides G. Okay now. So what is the means? Let ఇక్కడ ఏమొచ్చింది order of H is equal to P cyclic subgroup. Let H is equal to the cyclic subgroup generated by C. A group order P prime number అయితే every group of prime order is cyclic. Be a cyclic subgroup. Be a cyclic subgroup of G. Then order of C element is equal to group order is equal to P. So cyclic group definition itla kuda వచ్చు. Element order group order equal that group is also. What is the C is? Cyclic group. Element order group order equal. Subgroup order P element order group order equal that group is called as cyclic. This implies there exists an element C belongs to H subset R equal to G whose order is P, whose order P, that is clearly order of C is equal to P. Where is the C? Element of G indirectly. Where is the C? Is element of G order. నేను ఏం తీసుకున్నాను? P divides group order G. P is the prime number. P divides group order G. We have to prove G has one element. G has one element. One element is C. C is the one element of G. That order is P. That is what is the Cauchy's theorem statement? What is the G be a finite abelian group? P be a prime number. P divides group order G is equal to N. P divides group order N. Then G has an element of P divides group order G. G has an element of order P. What is the Cauchy's theorem? The Cauchy's theorem will be discussed only element order. P divides group order G. Then G has an element of order P. One case we can show me element of order P. We are go to the case 2. This is the case 2. What is the case 2 dictation? Let G be not a cyclic group. First case is cyclic group. This G is not a cyclic group. Not a cyclic group at then G not equal to cyclic subgroup generated by B. So for all B belongs to G. So this is a B and a compulsory with B is a proper subgroup of G. B proper subgroup of G. B proper we have in two cases. So we have to P divides group order cyclic subgroup generated by B. One case or P does not divide the group order cyclic subgroup generated by B. So if I am taken, if P divides the cyclic subgroup generated by B. So since I am taken the cyclic subgroup generated by B, so is a group of order G. So group order G. Enduku already they can do right. This is cyclic. This is a proper subgroup of G. Proper subgroup of G. This is a proper subgroup of G, subset of G. For our assumption, so group order G, ante that is a group cyclic subgroup generated by group order G is equal to N, less than N. From our assumption that the result is true. What is the result is? M is less than N. So from our assumption that the result is true for all groups of order, M is less than N is true. This is a true. Therefore, there exists has an element. What is the element to say X0? Say element X0 such that order of X0 equal to P. Order of X0 equal to P. So therefore, there exists is X0 element of this way subset of G such that order of x not equal to p, order of x not equal to p. This is the first, this is the case. Into two cases. What is the one case? P divides the cyclic subgroup generated by the element of order p. Second case is, what is the second case? If P does not divide prime number, the cyclic subgroup generated by B, either what is the situation? We have is clear. Order of G by, so cyclic subgroup generated by B, so that is called as quotient group. What is order of G by order of cyclic subgroup generated by B? Order of cyclic subgroup generated by B. Order of A is equal to, order of A is equal to the order of cyclic subgroup generated by B. So into the order of G by cyclic cyclic subgroup generated by B. So okay. So what is the, this is the situation. Suppose in star equation. So every prime number divides. So prime number is a P divides group order G. What is the group order G? Sorry, order of G. So order of G is equal to this way. P divides group order G. What is the P divides order G is equal to this is way. Order of cyclic subgroup generated by B into. So this is order of quotient group G by cyclic subgroup generated by quotient group. So manaku P divides already in this case. What is the case? P does not divide cyclic subgroup generated by this case called 100% ఏమైతది? This implies P divides only order of cyclic subgroup generated by B. Okay. Does not divide the cyclic subgroup generation. So since I am taken, since G by the cyclic subgroup generated by B is Hebelian. So this is a Hebelian. So hand G by Hebelian. So G is a cyclic subgroup is a Hebelian. Quotient group is Hebelian. I think the order of, this is the order of G by cyclic subgroup generated by B is less than order of G. Order of G and N. So order of G is N. So order of G is N. So the order of cyclic subgroup generated by G, this is a quotient group is less than N. The theorem result is true. The theorem result is M is less than whose order is true. At this element, what is the quotient group? Quotient group whose element? So from our assumption that the result is true for all groups of order who less than N. So from our assumption that the result is true for all groups of order whose order is less than N. What is the result is G by cyclic subgroup generated as an element, quotient group an element. What is the element is say? That is the element is say A B bar or A bar is equal to A plus cyclic subgroup. At is a coset element. Manaku X bar is equal to X plus H antam kada. That is the coset element. Ikkada H in plus is cyclic subgroup. This is the belongs to G by cyclic subgroup generated by A. So that is the element order. It is a equal from. That is the element order such that. So what is the order of A bar is equal to P, where small a is element of G. That is, let order of A is equal to K. So that is implies if and all of A power of K is equal to E. So now I am taken. This is a clear. Now it is a. So this is. Now I am taken. So now this is. Now I am taken. A bar whole power of K. A bar whole power of K. A bar is means A plus cyclic subgroup generated B whole power of K. How much times? A plus cyclic subgroup generated by B into first case, second case. A plus cyclic subgroup generated by second case up to so on. A plus cyclic subgroup generated by B third case. So this is A times A second time, third time. How many times? In K times? 40 A power of K plus cyclic subgroup generated by B. So A power of K is a B. E plus cyclic subgroup generated by B. E plus cyclic subgroup generated by is means E bar. E bar. And this is A bar whole power of k is equal to E bar వచ్చింది. సో ఆల్రెడీ ఆర్డర్ ఆఫ్ ఏ బార్ ఈజ్ ఈక్వల్ టు పి తెలుసు, అంటే ఏ బార్ హోల్ పవర్ ఆఫ్ పి ఈజ్ ఆల్సో ఈ బార్ అని తెలుసు. ఈ రెండింటి రిలేషన్స్. సో వాట్ ఈస్ ద రిలేషన్? ఈ దోస్ టూ రిలేషన్ అంటే ఏమొచ్చింది? ఆర్డర్ ఆఫ్ ఓకే ఏ బార్ హోల్ పవర్ ఆఫ్ కే ఈజ్ ఈక్వల్ టు ఈ బారే, ఏ బార్ హోల్ పవర్ ఆఫ్ పి ఈజ్ ఈక్వల్ టు ఆల్సో ఈ బారే. సో ఈ పి అండ్ కే రిలేషన్ బిట్వీన్ అంటే మీకు ఒకటి చెప్తాను చూడండి. -1 ఆర్డర్ ఆఫ్ -1 ఈజ్ ఈక్వల్ టు 2. -1 హోల్ పవర్స్ ఎట్లుంటాయి? 2 or 4 or 6 or 8 like that. ఈ 2 4 relation, 2 is less than 4, 4 is less than 6, 6 is less than 8. What is the relation? 2 divides 4 and 2 divides 6, 2 divides 8. What is the relation? 2 less than 4, 2 less than 6, 2 less than 8. We know divides the relation. The relation P and K relation. P and K relation. P divides K. P divides K. And what is the relation? K is less than N. ఇప్పుడు చెప్పాను కదా 2 divides 4, 2 divides 6, 2. What is the relation? 2. So P divides K. So let H is equal to, so this is H is equal to the cyclic subgroup generated by A, be a subgroup. So this is H is equal to be a cyclic subgroup, be a cyclic subgroup generated by subgroup, be a cyclic subgroup generated, so generated by G, subgroup generated by G. The element of order is equal to what is the cyclic group? Cyclic group element order, group order equal, that element order, group order equal, that group is called a cyclic group. Order of A is equal to K. So order of H, order of A is equal. What is the order of A? Already K తీసుకున్నాను. So and P divides group order H. So P divides group order H and order of H is equal to K. So this is a K is less than N. So malla once again, what is the K? P divides group order H. P divides group order H. P divides group order H. Order of H is P divides a subgroup order divides H. P divides, what is the K? Kada P divides K తీసుకున్నాను. P divides K. What is the K? Element of order H. So order of H is equal to K less than N వచ్చిందంటే our assumption by therefore by our assumption there exists x1 is element of H such that order of x1 is equal to, by our assumption M is less than N or K is less than N, the assumption that the theorem result is true for all groups of order less than N. Groups of order less than N కంటే తక్కువ any group order వస్తే that group is the theorem result is true. What is the theorem result? Any prime number P divides a group order G, that G has an element of order G. Yes, I'm taken. P divides order K, P divides order H. P divides order H. ఇక్కడ K is less than, order H is less than N. P divides order H. H has a subgroup. H has a one element is a element of order P. H has one, which has an element. What is the element? X1 is the element of H, such that order of X1 is equal to P. So that is the clear. The theorem is closed. There exists an element. Element X1 is belongs to H, such that so order of X1 is equal to P. X1 is element of H, that order of X1 is equal to P. This is the theorem is. Case is G is a cyclic group, theorem proof. G not cyclic group. G not cyclic group lo two cases. P divides order of divided by cyclic subgroup generated. P does not divide a cyclic subgroup generated by B. First one, G cyclic group అయితే automatically theorem proof continue అవుతుంది. So second case is G is not a cyclic group lo, again sub two cases divides a cyclic subgroup generated by B. P does not divide the cyclic subgroup generated by. In three cases total, so element order. P divides, P is a prime number, G is a abelian group, order of G is equal to N. P divides group order G. P divides prime number, where prime number, P divides group order G, where G has an element of order P. The Cauchy's theorem will be discussion is wholly element order. Next to Silo theorem. The Silo theorem will be discussion as subgroup order. Very, very important. Tomorrow, it is a morning class. Silo first theorem, Silo second and third theorem, and Silo problems. Silo first, state and prove that Silo first theorem, state and prove that Silo second and third theorem. Say a group order G is equal to 63. It's not simple. A group order 56 is group A, not a simple. Group of 36, 63, 56, 36 is a not a simple and a problems ఉంటాయి. Already నేను సెండ్ చేశాను నోట్స్. This is a clear, all of you. Okay, this is a today class is this way. Anyone doubts student? ఇక్కడ ఈ క్లాస్ లో BREOU హైదరాబాద్ సెంటర్ వాళ్ళు ఉన్నారా? 17 మెంబర్స్ ఆర్ దేర్. 17 మెంబర్స్ లో సో ఇక్కడ నేమ్స్ ఒక శిరీష పడుతుంది. ఇంకా ఎవరైనా ఉన్నారా? అర్థమవుతుందా? లక్ష్మి, వీళ్ళు ఆల్ ఆఫ్ యూ, రమాదేవి, రవికుమార్, స్రవంతి అండ్ దిస్ వే వరలక్ష్మి. సో ఇట్ ఈస్ all of you this way. Today we're learning important Cauchy's first theorem. Tomorrow Silo first theorem and Silo second and third theorem. It is some problems are there. చెప్పండమ్మా. హలో, ఎవరు మాట్లాడతలేరు కదా? ఓకే, నేను నోట్స్ ఆల్రెడీ గ్రూప్ లో సెండ్ చేశాను. ఇంకా రేపు ఏమైనా మిగిలిన నోట్స్ ఉంటే సెండ్ చేస్తాను. ఇవాళ నేను చెప్పింది మీరు చూడండి, అవే నోట్స్. మొన్న చెప్పినవి కూడా కొద్దిగా మీ టెక్స్ట్ బుక్ లో అటు ఇటు ఉంటాయి. నేను ఇచ్చిన నోట్స్ లో కూడా కాన్సెప్ట్ విల్ బి సేమ్. గ్రూప్ దగ్గర జీ దగ్గర క్యాపిటల్ ఏ ఉండొచ్చు, కాబట్టి మీరు అట్లా కాకండి. కానీ యూ కెన్ డూ నోట్స్. మీరు పీడిఎఫ్లే పంపించాను కాబట్టి వీ కెన్ టేక్ ఇమీడియట్లీ ప్రింట్ అవుట్. మీకు రాసేంత టైం లేదు కాబట్టి మీరు ప్రింట్ అవుట్ తీసుకోండి. ఓకేనా? మాక్సిమం టుమారో 5th యూనిట్ ను క్లోజ్ చేద్దాం. 5th యూనిట్ క్లోజ్ అయిపోయిందంటే నెక్స్ట్ ఫైనైట్లీ జనరేటెడ్ కూడా 6th యూనిట్ చూద్దాము. సో నెక్స్ట్ రింగ్స్ టాపిక్ ఉంటుంది. రింగ్స్ లో అక్కడక్కడ ఇంపార్టెంట్ చెప్పుకుంటూ పోతాను. సో ఓకేనా
సార్? ఏ గ్రూప్ లో పెట్టారు సార్? అది మామూలుగా
ఆల్జీబ్రా గ్రూప్ లో పెట్టారు.
ఆల్జీబ్రా గ్రూప్ లో బిఆర్ఏ ఒకటే గ్రూప్ ఉంది కదా. ఇక్కడ 10 గ్రూపులు ఎక్కడ ఉన్నాయి? నేను ఒకటే గ్రూప్ బిఆర్ఏ ఓయో ఆల్జీబ్రానే ఉన్నది. ఇంకా 10 గ్రూపులు లేవు.
సార్ లింక్ పంపించారు సార్, ఆ గ్రూప్ లో రాలేదు.
నేను పెడతా గ్రూప్.
ఎవరైనా ఉంటే పంపించండి కొద్దిగా.
ఓకే ఓకే.
చాట్ లో లింక్ పెట్టాను కదా, ఆ గ్రూప్ లో ఉన్నాం మేము. ఆ గ్రూప్ కు పంపించండి.
సరే, ఓకే, సరే అమ్మా. సో ఎవరికన్నా రాకపోతే వాళ్ళు నా నెంబర్ కు వాట్సాప్ చేయండి. దాంట్లో నేను యాడ్ అన్న చేస్తాను, లేకపోతే ఆ నోట్స్ అన్న సెండ్ చేస్తాను మీకు. సరేనా?
ఓకే సార్, థ్యాంక్ యూ.
ఓకే, రైట్.
మీరు పెట్టండి మేడం గ్రూప్. ఆ గ్రూప్ లింక్ అన్న పెట్టండి, లేకపోతే మా గ్రూప్ లో నోట్స్ అన్న పెట్టండి మేడం.
ఇలా 2 గ్రూపులు లేవు. నేను ఒకటే బిఆర్ఓయు ఆల్జిబ్రా బిఆర్ఓయు హైదరాబాద్ అని ఒకటే ఏదో తయారు చేశారు కదా, సులక్షణ అని ఈ స్టడీ సెంటర్. అదొకటే
మా దగ్గర గ్రూప్ అనే ఉంది సార్. అయితే ఆ గ్రూప్ లింక్ పెట్టండి సార్ మా మీటింగ్ లో. ఈ మీటింగ్ చాట్ లో పెట్టండి, మీరు ఏమనుకోకుండా.
సరే, ఓకే. ఇక్కడ 2 గ్రూపులు చేయలే, నేను ఒకటే గ్రూప్ చేశాను. ప్లీజ్ వేరే వాళ్ళకి
గ్రూప్ లింక్ పెట్టండి సార్.
ఓకే,
పంపించండి సార్.
ఓకే, థ్యాంక్ యూ.
జాయిన్ అయిపోతాము. ప్రతిసారి అడగాల్సి వస్తుంది.
ఏం కాదమ్మా, అట్లా అమ్మా ఇండివిజువల్ గా మీరు ఫీల్ కాకండి. ఇండివిజువల్ గా నా నెంబర్ కు వాట్సాప్ చేయండి. సార్ నాకు టుడే నోట్స్ అన్ని జస్ట్ ఇట్లా కొట్టండి, మీకు పంపిస్తాను. సరేనా? సో
గ్రూప్ లింక్ పెట్టండి సార్. గ్రూప్ లింక్ పెడితే మాకు ప్రతిసారి అడగాల్సిన అవసరం ఉండదు కదా.
ఓకే, ఓకే. ఫస్ట్ మీరు చదవడానికి ట్రై చేయండి అమ్మా. ఇవి గ్రూప్ డిస్కషన్ అనేది ఇంపార్టెంట్ కాదు. ఫస్ట్ పుస్తకం తెరిచి నోట్స్ ప్రింట్ అవుట్ తీసుకొని చదవడం స్టార్ట్ చేయండి ఫస్ట్. ఓకేనా? రైట్, రైట్ అమ్మా. 11:30.
థ్యాంక్ యూ సార్.
థ్యాంక్ యూ సార్.
మేడం గ్రూప్ లింక్ అయినా పెట్టండి, లేకపోతే నోట్స్ అన్నా సెండ్ చేయండి. నోట్స్ సెండ్ చేశారు, గ్రూప్ లింక్ పెట్టండి ప్లీజ్. ప్రీవియస్ క్లాస్ నోట్ కూడా పెట్టండి మేడం. వరలక్ష్మి మేడం ఉన్నారా? వర్రి లక్ష్మి గారు.
హలో మేడం, చెప్పండి.
ప్రీవియస్ క్లాస్ నోట్స్ ఉంటే కూడా బెటర్, కొద్దిగా ఏమనుకోకుండా.
మేడం నేను కూడా గ్రూప్ లో లేను మేడం, ఆల్జీబ్రా గ్రూప్ లో. ఈ బిఆర్ఏ మ్యాథ్స్ గ్రూప్ మాత్రమే ఉన్నాను మేడం.
ఆ,
ఇప్పుడు లింక్ షేర్ చేయమని చెప్పారు కదా, నేను వెయిట్ చేస్తాను దానికోసం.
ఓకే ఓకే
ఓకే.
థ్యాంక్ యూ.